Good morning, students. Hope you liked the last class. Okay, there we studied lenses, different types of lenses. How are the image formed by a convex lens, image formations by a concave lens, right? We also studied about the lens formula, magnification, and the relationship between V, U, H dash, and H. Okay, so now today, based on these formulas, we are going to solve some numericals based on lens formula. Okay, let's proceed. Right. So first thing, whenever you solve a numerical, just see or just observe which type of a lens it is, whether it's a convex lens or a concave lens. That thing will give you a lot of information regarding what is going to happen, right? So as the question says, an object is placed vertically at a distance of 20 centimeters from a convex lens. Okay, so now which type of lens do I have? I have a convex lens. Convex lens. Object is placed vertically at a distance. That means my object distance is going to be 20 centimeters. But how is this 20 going to be? Positive or negative? We know object is always towards the left side, and left side sign convention is negative, right? If the height of the object, okay, height of the object is also given, h is equal to 5 centimeters, and it is always erect, so it's going to be plus 5. Just to tell you, here I am using h as my object height and h dash as my image height. Okay, so keep that in mind, because some textbooks says object height as h1 and image height as h2. So remember this. Okay, coming back, focal length of the lens is given. Focal length is f. Focal length, you know, okay, as it is a convex mirror, this is the principal axis. Parallel rays are converged at a point in front of the lens. So when we know that it is in front of the lens, okay, so this is positive. Okay, so focal length of a convex lens is going to be positive. So this will be f, and focal length of the lens is 10 centimeters. So it's going to be plus 10 centimeters. Right, now what do we need? We need the position. That means we need to find out V, nature, size, and how much bigger. That means we need to find out magnification as well, size, so we need to find out h dash as well. Okay, all things can be done. First of all, we have u, we have f. So what is our lens formula? Our lens formula is, lens formula says 1 upon v minus 1 upon u is equal to 1 upon f. What do we need? We need v, so let v be at LHS. Let us shift this u to other side. So therefore 1 upon v is equal to 1 upon f plus 1 upon u, right? So now just put in the values. 1 upon f, so f is your 10 plus u is going to be, so 1 upon minus 20. So can this be written as this? 1 upon v equal to 1 upon 10 minus 1 upon 20. Yes, can be written, which is equal to, let us take the LCM. LCM is going to be 20. So I know 10 2s are 20. So 2 minus 1, 1 upon v. 1 upon v is going to be 1 upon 20. So therefore v is going to be plus 20 centimeters. So what is the plus sign indicates? Plus sign indicates that it is a real, because it is forming on this side, right? On the other side of the lens, so it's going to be real and inverted. Understood? Okay. Then okay, we'll write the entire statement at the end. Now v is done. Okay, for m to find, first we need to find out h dash, image height, and according to the relationship of 4 things, we know that v upon u was equal to h dash upon h. So therefore h dash will be equal to h into v by u. Yes, we can do that. So therefore, now just substitute the values. What is h? H is given as 5 into what is v? We calculated as 20 whole upon minus 20. 20 is going to get cancelled, but this negative will remain with h dash. So therefore, h dash is going to be minus 5 centimeters. Right? Okay. So height of the image is equal to 5 centimeters. What does negative sign indicates? Negative sign again indicates that it is real and inverted. So this is your nature. Okay. As you see, object and image size is same. So therefore your magnification will also be 1. H dash upon h. So that's going to be 5 upon 5 minus 5 basically upon plus 5. It's going to be minus 1. Magnification is 1. That means it has not, how much bigger will the image be as compared to the object? The image will be of the same size, right? Image is going to be of the same size. So at the end, you write an entire conclusion that the image is formed at a distance of 20 centimeters on the other side of the lens. Positive sign indicates that the nature of the image is real and inverted. Size of the image is 5 centimeters, hence the image and the object are of same size. Understood? Now, we solved all this, okay? But initially only when you read the question, from that only you should get an idea that this should happen. Why? Because what was the focal length given? Focal length was given as 10. What was the object distance? Object distance is given as 20. And we know that this object distance is double the focal length. That means the object should be at center of curvature. So that means the object should be at 2f1. Understood? Okay. This is the way you should find. Now, sometimes what happens is in this is the case. In such scenarios, they also ask you to draw a diagram. So you know what diagram you have to draw. At center of curvature, that means if the object is at 2f1, image is formed at 2f2. That same diagram you should be able to draw it, right? Okay, let's proceed. Okay, question number 2 says 5 centimeter height object is placed at a distance. Okay, so 5 centimeter height of the object. So object height h is equal to 5 centimeters. Converging lens is given. We know what's a converging lens. So converging lens will always be a convex lens. Okay. Object is placed at a distance of 25 centimeters. So u will be equal to minus 25 centimeter. Right. Focal length is given. F is equal to 10 centimeter. And we know as it is a convex lens, all the rays get converged. All the rays, this is a convex lens, parallel rays getting converged at this point. What is the sign convention here? Sign convention is positive. So focal length of a convex lens is positive. Similarly, just to tell you, give you an idea, focal length of concave lens will be negative because it's a diverging lens. We take the rays behind and it is coming from a point behind the lens, that is on the same side of the lens. So sign convention over there is negative. So focal length of a concave lens is going to be negative. We need to find position, size, type of the image. Okay, so V is to be found, size H dash is to be found, nature, all these things will come now. Okay, U is there, F is there. So according to lens formula, what is our lens formula? Lens formula says 1 upon V minus 1 upon U is equal to 1 upon F. What do we want? We want this. Let's keep this over here, shift this over here. So 1 upon V is equal to 1 upon F plus 1 upon U, right? So just substitute the values. 1 upon V is equal to, so what is F? F is going to be 10, right? Plus 1 upon U. U is minus 25. So keep this minus. Do not remove the signs, right? Because otherwise your entire problem will go anywhere. So this is going to be 1 upon 10 minus 1 upon 25. What will be the LCM? LCM is going to be 50. 10 5s are 50, 25 2s are 50. So 1 upon V will be equal to 3 upon 50. So what will be V? V will be equal to 50 divided by 3. What is 50 divided by 3? Right, so V will be 50 by divided by 3, so that's 16.67 centimeters. So hence, image is formed at a distance of 16.67 centimeters on the other side of the lens. Positive sign shows that, because if it's on the other side, positive sign shows that it's real and inverted. So nature we got, now we need to find out H dash. Okay, we have the relationship H dash upon H is equal to V upon U. So therefore, H dash is equal to H into V divided by U. So now what is H? H is given as 5. 5 into V is, okay, now over here, just to avoid the calculations of 16.67, what we'll do, we'll directly write this as 50 by 3 upon U. What's U? U is minus 25. Okay, so that, did you understand why did I not take 16.67? Just to avoid the calculation. So 25 and 50 will go, right? So this will be 50, sorry, 5 into 25 and 50 goes to 2. So this is going to be minus 2, entire thing divided by 3. So negative sign is going to be there. So minus 10 upon 3. Minus 10 upon 3, that means minus 3.67 centimeters, right? So that is going to be height of the image, size of the image. So how is the height of the object was 5 centimeters, height of the image is 3.67 centimeters, which shows that the image is a diminished image. Okay, it shows that the image is a diminished image. So image is a diminished image. Position, real position is 16.6 centimeters on the other side of the lens, and the type of image formed is real and inverted. Okay, let's proceed. Third one, it says an object kept 60 centimeters from a lens gives a virtual image 20 centimeters in front of the lens. What is the focal length of the lens? It is converging or diverging, right? So it says now object is kept. So U is kept my 60 centimeters from a lens. It is giving us a virtual image V 20 centimeter in front of the lens only. So in front of the lens, that means on the same side. Okay, whenever it says it is on the front of the lens, it is on the same side. Now this is going to be 20 centimeters. What is the focal length we need to find? F, and we need to find the type of lens, whether it's concave or convex. According to the focal length, we can find which type of lenses it is, right? So we have our lens formula. 1 upon V minus 1 upon V is equal to 1 upon F. So therefore 1 upon F is equal to 1 upon minus 20 minus 1 upon minus 60. So this is going to be 1 upon 60, minus and minus will be plus, minus 1 by 20, right? Minus 1 upon 20. LCM will be 60, right? Okay. 60. 1 minus 23 is a, okay, 1 upon F. So therefore 1 upon F is equal to minus 2 by 60, which is equal to minus 1 by 30. So therefore F will be equal to minus 30 centimeters. Now what is the negative sign shows? Negative sign shows now this is a concave lens, because I'll just show you for explanation. In case of a concave lens, this is a concave lens, this is the principal axis. Now when rays are coming parallel from infinity, they get diverged. This is the diversion. Okay, but they appear to come from a point which is behind the lens in this way, right? So now this point becomes your focus 1, and the focus 1 is at this side. What is the sign convention over here? Sign convention is negative. So focal length of a concave lens is going to be negative. So as focal length is negative, we can say that the given lens is a diverging lens, right? It's a diverging lens with focal length 30 centimeters. Understood? How have I solved it? Right? Okay, let's proceed. Fourth one says, okay, again over here they have given concave lens has a focal length of 15 centimeters. So now directly they have given that yes, it is a concave lens, and we know when it is a concave lens, how is the focal length? Focal length is going to be negative. So f is equal to minus 15 centimeters. At what distance should the object be placed from the lens so that it forms an image at 10 centimeters from the lens? The image V is given as 10. What will be the sign of image? Concave lenses, how are the type of images formed? In concave lenses, the type of images formed are always virtual. Okay, if they are always virtual, so that means V is always going to be negative. So let us take this as negative. Right? So what do you need to find? You need to find over here is U. And we also have to find the magnification produced by the lens. Concave lens has focal length as given. What distance should the object be placed so that it forms an image of 10 centimeters from the lens? Right. According to the lens formula, we have 1 upon f equal to 1 upon v minus 1 upon u. We need 1 upon u, so I'll take this minus 1 by u over this side and take 1 upon f over this side. So minus 1 by u will be 1 upon u, 1 upon u, 1 upon v. This will be minus 1 upon f. Okay. V is minus 10, minus f is also negative, minus 15. So this minus and this minus are going to be positive. So this becomes plus 1 by 15 minus 1 upon 10. What will be the LCM? LCM is going to be 30 in this case. This is 1 upon u. 1 upon u is equal to 30. 15 twos are, 10 threes are, minus 1 upon 30. So u is equal to minus 30 centimeters, right? So we can say that the object should be placed at a distance, or because you have got as minus 30. So we can write the statement as object should be placed at a distance of 30 centimeters from the lens so as to get an image of 10 centimeters from the lens. And we know in case of a concave lens, the type of images, because see, as h is not given, right? As h is not given, we cannot find out h dash, and hence we cannot find out magnification. But they have asked us find the magnification produced by the lens. So in this case, what we'll write, magnification produced by the lens. We know that in case of a concave lens, the images formed are always diminished. But again, we have this formula that m is equal to h dash upon h, which is equal to v upon u. We don't have this, no matter. So you don't stop it over here. We'll directly use this formula. So m is equal to v upon u. What is v? V is your minus 10. What is u? U is minus 30. Minus minus is going to be plus. So m magnification is 1 by 3. Or you can say magnification is 0.33. Right? So image formed is 1/3 of the object. Right? Object height, it will be 1/3 of the size. It will be a diminished object. So m is equal to 1 by 3. Okay, and positive, it's positive, so positive sign indicates that it's virtual and erect. And anyways, we know in case of a concave lens, it's always going to be virtual and erect. Understood how to get an idea of. One more question we have. It says an object 5 centimeters in length is held 25 centimeters away from a converging lens. So this itself shows us converging lens. That means it has to be a convex lens. Okay, what all is given? Object height is given. So that's h. H is equal to plus 5 centimeters, right? Held 25 centimeters away, so U will be minus 25 centimeters. Focal length is given as 10 centimeters. So for a convex lens, how is the focal length? Focal length is positive, so it's going to be plus 10 centimeters, right? Draw, see now, draw the ray diagram, find the position, size, and nature of the image formed. Perfect. Now let's see. Now first, using our numerical method, let's find out first V. Okay, depending on the position of V, we can draw the ray diagram. So what is our lens formula? Our lens formula is 1 upon V minus 1 upon U is equal to 1 upon F. So 1 upon V is equal to 1 upon F plus 1 upon U. Let us apply this. 1 upon V 1 upon V equal to, what is F? F is plus 10, 1 upon 10 plus 1 upon minus 25. Okay, so this is 1 upon 10 minus 1 by 25, right? What is the LCM? LCM is going to be 50. 10 5s are 50, 2s are 1 upon V. 3 upon 50. We have already done a question like this. So V is equal to plus 50 divided by 3 centimeters it will be. So what will be V? V will be plus 16.67 centimeters. Right? We did this. So now let us try to, we found the position. Size. Okay. So size, we know H dash is equal to H into V upon U. Positive sign is here, so it's positive sign indicates that the image is formed on the other side of the lens. That means it is real and inverted. Let us first find out the size and then we can work out on the ray diagram. So H is given as 5 into V, as I've told you, keep this as 50 by 3 only, and divided by 25 minus 25 basically 2. So minus 5 into 2 whole upon 3. So that's going to be minus 10 by 3. H dash minus 3.33 centimeters. Right? Okay. So now as far as the ray diagram is concerned, so if I take, so let's start from here. Let this be my converging lens. Okay. This is the principal axis. Okay, I need to take it a little higher. Let this be the principal axis. Let us first mark all the important points. So this is your optical center. This is your F1. See the distance. Let this be your 2F1. Again, F2, 2F2. Now they say that the focal length is 10. So this distance is going to be 10. So this distance is also going to be 10. So total radius of curvature is going to be 20. And they say that the object is minus 25. So that means what is the position of the object? The position of the object is beyond 2F1. right? So if I am keeping my object over here, so now this object is beyond 2f1. Okay, object B, A and B. So what do I do? How will be my rays now? So one ray I take parallel to principal axis, pass through focus. Another ray I am going to take will pass through my optical center. Okay, so they are meeting over here. This is the meeting point. So this is where my image is formed, right? This is going to be A dash. This is going to be my B dash. So my if you observe, the object was 5 centimeters. The image is now 3.33 centimeters. It's a little diminished image. Okay. Object position was beyond 2f1. Where is the image formed? Image is formed between f2 and 2f2 because it is at a distance of 16.67. So f2 is like over here also, it will be like plus 10 and 2f2 is going to be plus 20. So it is in between that. Okay, nature real and inverted because it is formed on the other side, real, inverted, and size will be diminished because it is smaller than the object. Okay, so this is the way you should be able to solve such questions, right? Okay, next. Next we have a concave lens of focal length 15 centimeters forms an image of 10 centimeter from the lens. How far is the object placed from the lens, right? Okay, then let's see. Concave lens. First only they have told us that it's a concave lens. That means it's a diverging lens. Focal length will be negative. So that's minus 15 centimeter. Forms an image 10 centimeter. So image, that means V will be minus 10 centimeters. Why negative? Because it's a concave lens. Concave lens always forms a virtual image. It is always on the same side, and on the same side the sign convention is negative. So we need to find out how far the object is placed and also draw the ray diagram. First find out what will be U. One lens formula, 1 upon V minus 1 upon U equal to 1 upon F. This is your lens formula. So therefore we need to find out U. So 1 upon U will be equal to 1 upon V minus 1 upon F. This is equal to 1 upon minus 10 minus 1 upon minus 15. So that's 1 plus minus into minus is going to be plus. So plus 1 by 15 minus 1 by 10, right? So this is going to be 30 LCM. 2 minus 3, 1 upon U, right? So 1 upon U in this case is minus 1 by 30. So therefore U is equal to minus 30 centimeters. That means the object should be placed at a distance of 30 centimeters from the lens. Now as far as the ray diagram is concerned, right? So let us try to draw a ray diagram. What is this? This is a concave lens. What do we do? Let us first of all draw our principal axis. This is my principal axis. Once the principal axis is done, mark all the important points. Okay, so this is my M, N, optical center. This distance they are taking as F1. So this distance is again F2. Same distance to F1. Same distance to F2, right? Okay, so now according to this thing, it's minus 15. Okay, and object distance we got as minus 30. So this is minus 15. Focal length is minus 15. Okay, and object is placed at 30. That means 15 and 15. This entire thing is going to be 30 minus 30. So I will keep my object over here. This is my object. So let's name it A, B. It's a concave lens. Okay, remember it's a concave lens. So now let us draw our ray diagrams. First ray parallel to principal axis. Parallel to principal axis, it is going to get diverged. But when I bring it back, it is going to go through the focus. Right? This is the way. Second ray will be passing through your optical center. It is going to pass in the same way. Okay, now where are the 2 points meeting? The 2 points are meeting at this point. This is the point of meeting. So this is where my image will be formed. This will be A dash, it will be B dash. So as you can see, as the object U, we got it as minus 30. Image distance was given to us as minus 10. That means it was between focus and optical center. So this is where image is formed. It's minus 10. It's less than 15 centimeters. Understood? So this is your ray diagram. This is the way you should interpret the ray diagrams, right? So now, okay, nature obviously on the same side. So it's going to be virtual and erect. Okay, magnification you can find out, it's not asked, but you can find out m is equal to v by u. So what is your v? V is minus 10, minus 30, 1/3, right? Okay, let's proceed with one more question. Okay, now this is going to be a very, very important question. Okay, very interesting. Normally comes in your school examinations, prelims, sometimes in boards as well. Okay, it says 1/2 of a convex lens is covered with a black paper, right? Will this lens produce a complete image of the object? Verify your answer experimentally, explain your observations. Okay, it says that now we have a convex lens. Okay, so let us draw a convex lens. This is my convex lens. Let this be the principal axis. Now, any 1/2 is covered with the black paper, right? So, so for example, I cover this first half with the black paper. Okay, now I have kept an object over here. Let this be the object. I need to find whether an image of this object will be formed or not. Okay, can you tell me whether it will be formed or it will be formed half? How will be the scenario? The image of the object will be formed, because see, when we draw ray diagrams for our own convenience, we take only 2 to 3 rays. Okay, now here we take only one ray, well, only 2 rays, okay, to find out the images. But actually in reality there are millions of rays which are coming out, millions and millions of rays which are coming out from this object, right? Though the first half of the lens, right, though this first of the half of the lens is covered, but the second half of the lens is also there, right? So this second half is open, so the image will be formed. Okay, image will be formed. But what will be the difference? So if I take, for example, one ray which is passing through optical center, and if I take that, okay, this is my optical center, this is my f1, let this be my 2f2. Okay, another ray, how will I take another ray passing through focal length parallel to the optical center, right? Yes, my image is formed, yes or no? So the image is formed over here. Okay, image is formed, but how will be the image? Okay, they have asked, will this lens produce a complete image of the object? So for the first question, as far as the first question goes, yes, it will form a complete, first one will say, yes, it will form a complete image of the object. Image of the object, right? I'll take one more scenario. Now this first half is closed. I'll take one more scenario wherein I will close the second half. Okay. Let's consider the second half is covered with black paper. Okay. As far as the second half is covered with black paper, consider an object again which is kept over here. There wouldn't be any difference because we know one ray parallel passing through focus, another ray passing through optical center. We are going to get our image anyhow, right? Image formed will be here. This is where my image will be formed. Again, image in both cases, whether the first half is covered, whether the second half is covered, in both cases, image will be formed. Okay, verify answer experimentally. We verified it experimentally as well. Explain your observations. Okay, now as far as the observations are concerned, we need to write it over here. If you observe, see, we know that millions and millions of rays are coming out from this object. Okay, so when we cover half of the lens, half of the light rays are obstructed. Yes or no? Okay, so for example, just for an example, when I say that millions and millions of light rays are coming from this object, from the entire object, basically, we just take the top of the object. So out of these million rays, these rays, okay, are obstructed. That means 50% of the light is less, which is passing through the lens. Okay, so this tells us that yes, the image is formed completely, but as far as the intensity of the light is seen, intensity of the light of the image will be reduced by 50%. Okay, 50%, or we can say it is reduced. So observations tell us that observations, yes, the image is formed, complete image is formed, but intensity of light, but intensity of light is reduced, intensity of light. Okay, so as the intensity of light is reduced, how will be the image seen? Image will be there, but it will be faded. It will be not as strong when the lens was not covered. Okay, so the image appears faded. Right? Understood? Quite interesting question. Okay, so keep this in mind. Hope you got a good idea regarding all your numericals. Okay, we will solve some more numericals when the entire chapter is done. Mostly numericals which have come in past papers from board examinations. Okay, next class we'll do the topic of power of a lens. What do we mean by a power of a lens, and in which situation which type of power is used, right? So stay tuned, practice your numericals. See you soon now. Okay, bye bye.